Hello chemistry students, Dr. Tullis here. We are starting chapter 8 over chemical reactions. You will be able to write chemical reactions, balance them, and then classify what types of reactions they are. Let's get started. This chapter's career focus is on the exercise physiologist. They work with athletes as well as patients with chronic conditions. They evaluate a patient's health and create individual exercise programs, and they monitor the patient and change the exercise program as needed. Section 1 is looking at equations for chemical reactions. You will be able to identify a balanced chemical equation and determine the number of atoms in the reactants and products. A chemical change occurs when a substance is converted into one or more new substances. When silver tarnishes, silver metal reacts with sulfur to form a black substance we call tarnish. The chemical name would be silver sulfide. We would write this chemical change as Ag, silver, reacting with, that means plus, sulfur to form Ag2S. Here's some evidence that a chemical reaction happened. We have a change in color. For example, iron nails change color when they react with oxygen to form rust. There is a formation of a gas, or bubbles form. Bubbles form when calcium carbonate reacts with an acid. There's a formation of a solid, or a precipitate forms, and in this case a yellow solid forms when potassium iodide is added to lead nitrate, or heat is produced or heat is absorbed. Methane gas burns in the air with a hot flame. Let's look at how to write a chemical reaction. When charcoal is burned in a grill, the carbon in the charcoal combines with oxygen from the air to form carbon dioxide gas. This is our word equation, and now we're going to put it into a symbolic form. So here's our equation in symbols. We have the carbon, which is solid because it's charcoal, reacting with oxygen in the air, and whenever oxygen is by itself, it is diatomic, so we would say O2 in gas form. And then the arrow tells us that they react to form, and then our product is CO2, carbon dioxide gas. Here are some rules to go by when we're writing chemical equations. Reactants are written on the left, products are written on the right. If we have two or more substances on one side, we separate them by a plus sign. The delta sign, this triangle, indicates that heat is used to start the reaction. And like we just showed in this last slide, when we had solid carbon and gaseous oxygen and gas carbon dioxide, physical states are abbreviated. Solid is S, liquid is L, gas is G, and aqueous is AQ. Here's a table to help us see that a little bit better. How to identify a balanced equation? When a chemical reaction takes place, the bonds between the atoms of the reactants are broken and new bonds are formed to give our products. All atoms are conserved, however. That means that atoms cannot be gained, lost, or changed into other types of atoms. Every chemical reaction must be written as a balanced equation. Must be written as a balanced equation. That shows the number of atoms for each element on the left and on the right. They need to be the same. Let's look, for example, at this equation. Hydrogen gas plus oxygen gas gives me water in gas form. Notice that there's these blue 2's in front of the H's. Why is that? Well, let's pretend for a minute that there wasn't a 2. I'm going to scribble this out for a minute. On the left, I have 2 H's and I have 2 O's. On the right, I have 2 H's. Good, those match. But look, I only have 1 oxygen on the right. I need another. Now, it would be easy enough to just put a 2 on the right side here of that by that oxygen, but I'm changing the chemical by doing that. It's no longer H2O water. H2O2 is a substance called hydrogen peroxide. So we can't just put a little 2 and change that substance. I have to put a number in front of. This is called a coefficient. Now this 2 tells me that I have 2 H2Os, so we think in multiples here. 2 H2s would be 4 H's, and 2 oxygens would be 2 O's. On the left here, I have 2 O's now, so that's good. They match. Those are good. Therefore, I had to put a 2 in front of the H2 to give me 4 H's. And now we're balanced. Like we just said, every chemical reaction is written as a balanced equation such that the numbers of atoms of each element are the same in the reactants and the products. And to do that, we use coefficients written in front of chemical formulas. Let's continue looking at this equation that forms water. Notice when I put 2 H2s, I have one H2 and a second H2. And on the right side, because I have 2 waters, I have 1, 2, 3, 4 hydrogens. Notice that they have been rearranged. We have new bonds that are formed because these bonds on the left have been broken. We broke apart 1, 2 H2s, and we formed 2 bonds there and 2 bonds there to form water. Notice that we also broke apart our O2, and we have 1 oxygen there and 1 oxygen there. This breaks it down even further. I have 4 H's on the left and I have 4 H's on the right. 2 O's on the left and 2 O's on the right. Why don't you take a minute and figure out how many of each type of atom are in the following balanced chemical equation. Let's see how you did. By looking at this first part, I have 2 Fe's, I have 3 sulfurs, and then simply because it wrote 6 HCl, this 6 is going to distribute to the H and the Cl. So I would have 6 H's and 6 chlorines. Let's look at the right side. I have 2 FeCl3s. That means I have an FeCl3 and a second FeCl3. So I have 2 Fe's, 3, 6 chlorines, and then I have 6 H's because that 3 distributes. I did have 1 H2S, but now I have 3 H2s, so that would be 6 hydrogens and 3 sulfurs. Take a look at the learning goal to make sure that you understand this first section. In section 2, we are going to focus on how to balance a chemical equation. So your learning goal is to be able to write a balanced chemical equation from the formulas of the reactants and the products for a chemical reaction. Let's look at a sample problem. We have the reaction of methane gas and, that means plus, oxygen gas to produce, that's our arrow, carbon dioxide gas and water. Again, that's a plus in between there where there's an and. Let's write the balanced chemical equation for the combustion of methane. We're just taking what we got from the word problem. So we have CH4 plus O2, both of those are gas, react to form, there's our arrow, CO2 and H2O. Let's count how many atoms of each we have on the reactant side and on the product side. This is what I like to do. I like to draw a line underneath of the arrow to separate my reactants and my products. And then I write down each of the elements that I see on the left and match them up with the same elements that are on the right. On the left, I then do an atom count. I have 1 carbon, 4 H's, and 2 O's. On the right, I have 1 carbon. Here's 2 O's, but there's another O, so that's 3 O's. And 2 H's. We can see here that my carbons are balanced, that's good, but notice on the left I have 4 H's and on the right I have 2. That's not balanced. And on the left I have 2 O's and on the right I have 3. That's not balanced. So here's what I like to do. I go, okay, the top one, carbon, we're good. Let's move on to the next one. Hydrogen. All right, who needs more? The right side needs more, and we need to think in multiples. In multiples, how do I get my right side 2 to equal the left side 4? Well, I need to multiply the right side by 2. So find where your hydrogen is, and let's put a 2 in front of that H2O, because that's where the hydrogen is. That 2 will distribute to the H and the O. So I no longer have 2 H's, I have 4 H's. And I no longer have 1 oxygen there, I have 2 oxygens there, plus the 2 oxygens and the CO2. So that's 4 O's. Okay, top down, let's do a check. Carbons are good, hydrogens are good. Now I need more oxygens on the left. And again, thinking in multiples, if I have 2, I need to multiply by 2. So we find where our O is, and we put a 2 in front of that O. Now I have 4 O's on the left. Now everybody is matching. We haven't created or destroyed any atoms. We are balanced. This shows us pictorially that we are balanced. That I have 1 black carbon here on the left, and there's 1 carbon on the right. On the left here I have 4 white hydrogens And on the right, I have 1, 2, 3, 4 hydrogens. On the left, I have 1, 2, 3, 4 red oxygens. And on the right, I have 1, 2, 3, 4 red oxygens. Sometimes the coefficients of the compounds in an equation need to be increased to give whole numbers for the coefficients. Then we just need to adjust the coefficients and count the total atoms on both sides once again. Sometimes you need to go through your list of balancing more than once, going from top to bottom. Let's do a sample problem. Acetylene, C2H2, is used to produce high temperatures for welding by reacting it with oxygen. So we've got this plus oxygen to produce CO2 and H2O. All of the compounds are gases. Let's write a balanced chemical equation. Here we go. We've got our acetylene plus oxygen to give us CO2 and H2O. It is not a balanced equation. Let's write down what we know. On the left I have CH and O. On the right I have CH and O. Let's do an atom count. I have 2 carbons. I have 2 H's. I have 2 O's. On the right I have 1 carbon, 2 H's, 2 plus 1 is 3 O's. Let's go top down. Top, I can see that on the left I have 2 carbons, on the right I have 1. So who needs more? My right side. And in multiples, I need to multiply that 1 by 2 to give me 2. Don't think adding, think multiples. So that gives me 2 carbons. It's going to mess with my oxygens. That gives me 4 O's there plus 1 O, so that's 5 O's. Let's look now. Our carbons match, good. Our hydrogens match, good. Now look at our O's. I have 2 O's on the left and 5 O's on the right. How can I get to 5 from 2? Again, you got to think in multiples. Well, 2 times 2 is 4. 2 times 3 would be 6. So what's in between 2 and 3? 2.5, right? If I put 2.5 in front of O2, 2.5 times 2 would give me 5, but I can't have a part of a coefficient. I need it to be a whole number. Well, in that case, I have to double everything in my equation. That would give me a whole number. So I'm going to say, well, I did have one of these, so I'm going to double and make this 2. I'm going to double this 2.5 to make it 5. I'm going to double this 2 to make it 4. And there was nothing in front of this H2O, so I'm going to double it and make it a 2. Let's do an atom count now. On the left, I would have 4 C's, 2 times C2. I would have 4 H's, and I would have 5 times 2 is 10 oxygens. Let's look at the right side. 4 times that 1 carbon would be 4 carbons. That would be 8 O's plus 2 O's from the water. That would be 10 O's. And let's look at our H's. 2 times 2 would be 4. Now we match. Sometimes an equation contains the same polyatomic ion in both the reactants and the products. If that's the case, we can balance the polyatomic ions as a whole group on both sides of the equation. Let's look at an example. Here I have sodium phosphate plus magnesium chloride, and it gives me magnesium phosphate and sodium chloride. So see how my PO4 and a PO4 is on the left and the right? That means I can keep PO4 as a unit together on both sides, on the left and the right. If there's PO4, or let's say it's carbonate, or any of the polyatomic ions, if you see it on the left and the right, we can keep it together. If not, then we need to separate them into just the elements that make it up. But let's look at this. We have Na3, and that 3 we know is there because phosphate has a -3 charge, and sodium has a +1 charge. So I need 3 +1s. That would give me +3, and 1 -3 to have a neutral compound. So we wouldn't say Na3 over here. We would say that we have 3 Nas. I have 1 phosphate. I have 1 magnesium, and I have 2 chlorines. On the right side, I have 1 Na, 1 Cl, 3 magnesiums, and 2 phosphates. Now let's look at this going top down. I can see up here on the right that sodium only has 1 sodium, and there's 3 on the left. So 1 times 3 would get me 3 Nas. That's also going to give me 3 chlorines. My Nas are good. Check. Let's go to the next one down. I have 2 phosphates on the right and 1 phosphate on the left. So let's double the phosphates on the left. If I double my phosphates, that means I have to put a 2 in front of here. That means that's going to give me 2 times 3, that's going to give me 6 NAs, and that's going to give me 2 phosphates. Now I always like to go back and go top down again. Oh, now I have 6 NAs and 3 NAs. So we need to back this up on the right and say, well, I did have 1 NA. I tripled it to get 3, but now I need to go and I need 6 NAs. So I can erase that first part because I needed to go back and fix it. I need 6, so that gives me 6 NAs and 6 chlorines. All right, so now we're back to having our sodium's good, our phosphates are good. Let's look at the magnesium. I need to triple the magnesium on the left, so I'm going to put a 3 in front of there. That gives me 3 magnesiums, and it gives me 6 chlorines. And that just made my magnesiums good, my chlorines match, sodiums match, and phosphates match. We are balanced. Take a minute to look over the review and make sure that you understand the learning goal for this section.